Circle geometry is quite a simple topic. The first thing that you should know are the parts of a circle. The first part that we are talking about is the chord. This is a chord. A chord being a straight line that divides a circle into two parts. The parts of the circumference will be this being the minor arc. This is the minor arc and this is the major arc. This is called the minor arc, this part, this line, because it is the smaller of the two arcs, and this is the major arc. And this is the minor segment, and this is the major segment. This is the major segment. This place here is the minor segment, and this place here is the major segment. So the chord divides the circle into two arcs, minor arc and major arc, and this minor segment and the major segment. If you are given this circle, a circle like this, with these angles A and B, this angle A and B, this angle A and B, this, and this angle A or B, So these three angles, they have similarities. Similarity number one, they are in the same major segment like this. If you draw a chord AB, you can see that these angles, these three angles, are in the same major segment, and also these three angles are subtended by the arc AB. So these three angles are subtended by the arc AB, this minor arc AB, in the major segment AB. Our theorem number one under circle geometry is that angles in the same segment of a circle are equal. Angles in the same segment of a circle are equal. So looking at this triangle, at this circle that we drew here, it means that angle AMB is equal to angle ANB and angle AOB. That is, this is equal to ANB, which is equal to angle AOB. Even angles in the same minor segment are equal. So given angles like this, this being angle X, this being angle Y, and this being angle Z, these angles are in the same minor segment and they are equal. So angle X is equal to angle Y, which is equal to angle Z. So whether it is a minor or a major segment, for as long as angles are in the same segment and are subtended by this in the same arc, they are equal. Theory number two. The angle in a semicircle is a right angle. So if the chord divides the circle into two equal parts, the chord is a diameter if it divides into two equal parts, and this angle is a right angle, that is 90 degrees, right? You know that. And even if we produce another angle, it will be a right angle, and even another one, it's also a right angle. So an angle in a semicircle is a right angle. Theory number three. The angle which an arc of a circle subtends at the center is twice that which it subtends at any point on the remaining part of a circumference. In simple terms, if we look at the three triangles, the three circles, I mean, this circle, you can write a chord here, you can put a chord here, and it seems like these two angles are in the same segment and they are subtended by the arc AB. This angle subtended on the circumference is half of this angle subtended at the center. So the angle subtended at the center is twice the angle subtended on the circumference, meaning the angle AOB is equal to twice the angle APB, which can be written as 2APB is equal to AOB. Even if you look at this circle, the angle that is subtended at the center by arc AB as this angle, this is twice this angle. And also, if you look at this, the angle that is subtended at the center, this angle is twice this angle. So the trick is that the angles should be subtended and they should have these two. The starting point and the ending point of the angles are similar. You see, APB, AOB. The only difference is that this is at the center and this is on the circumference. So if you see angles like this, you just know that the one at the center is twice the one on the circumference, given that they have the same starting and ending points and they are on the same arc. Example 1. Given this and you are told that you should find angle V and angle W. This is quite easy. The first step that we should take is to name our points on the circumference of the same circle. We can name this A and we can name this B. We can name this C and this D. And at the moment we have angle ACB, which is equal to 32 degrees. Angle AOB is the one that we are looking for. This is V degrees. And angle ADB, this is equal to W degrees. And you can see that all the three angles, they have the same starting and ending points. It makes it easy for us. Then looking at the three angles, angle ACB and angle ADB, they are both subtended at the circumference. And according to our theory number 1, these angles should be equal, because if we draw a line like this, a chord, it shows that these two angles are in the same segment. So angle ADB is equal to 32 degrees. Then moving to angle AOB. For angle AOB, we can see that it is subtended at the center instead of at the circumference. And according to theory number 3, this angle AOB should be equal twice the angle ACB. This is equal to 2 times 32 degrees. Therefore, angle AOB is equal to 64 degrees. This is easy, right? Example number 2. Given this circle, find angle Q and M. So we are given this circle, right? And we can see that this passes through the center. So this is a diameter. And we said angle in a semicircle, which makes this a semicircle. Angle in a semicircle, this angle is a right angle. So it means angle QMP like this is equal to 90 degrees, right? It is a right angle. Then if we have found this angle, this is a triangle. So in triangle QMP, in triangle QMP, we can see that this angle QPM, this angle, therefore angle QPM is equal to what? It is equal to 180. We all know that angles in a triangle add to 180, right? 180 minus 63 degrees minus 90 degrees. this 63 and this 90 degrees, which is equal to 27 degrees. So now we have angle QPM, this angle being 27 degrees. And we can see that the angle that we want is QNM. And we have QPM, this QPM, they all end with M. And if we look at it, QPM and QNM, they are subtended by the same minor arc QM, and so they are equal. Therefore, angle QNM, that is, let me write it correctly, QNM is equal to 27 degrees based on our theorem number 1. May you please pause the video and carry out the exercise that is on the screen. O is not a letter to be found, it is the center of the circle, but the other angles should be found. May you please pause the video and carry out the exercise that is on the screen. O is not a letter to be found, it is the center of the circle, but the other angles should be found. It is now time for the solutions. We will start with part A. We say the first thing that we do is to name our points on the circumference. This we will name it P, this Q, this R, this S, and T. Now after naming it, we then write the angles that we have as angles using the named points. The first angle is this, that is 40 degrees. This is angle PRT. So angle PRT is equal to 40 degrees. And the other angle that we have is angle RPS. Angle RPS. This is 32 degrees. And the angle that we are looking for, this is angle A. Angle A is angle PQT. Angle PQT is equal to A. And the other angle is angle PST. Angle PST, which is equal to B. And the last angle is angle RTS. Angle RTS, which is equal to C. After naming the angles, we then look for the angle that have the same starting and ending points. This angle and this angle and this angle, you have the same starting and ending points. And if we look at the angles, they start from P and end at T, and they start at P and end at T like this. So these angles are equal. These angles are equal because they are subtended by the same arc. Therefore, angle PRT is equal to PQT, which is equal to PST, which is equal to 40 degrees. Therefore, angle A is equal to 40 degrees, and angle B is equal to 40 degrees. Now we are left with angle C. This angle RPS and RTS, they have the same starting and ending points. So if we look at them like this, RPS and RTS, they are subtended by the same arc. Therefore, they are equal according to our first theorem. So RPS is equal to RTS, which is equal to 32 degrees. Therefore, angle C is equal to 32 degrees. We have finished number A. Now let us proceed to B. Solution for part B. The first thing that we do, we said we name the points. We can name the points A, B, and C, and D. After naming the points, we can write the angle that we are given. This is angle ABD, which is equal to 53 degrees. and we also have angle DBC, which is equal to K, and angle DCB, this DCB, which is equal to L. So we are looking for angle K and angle L, and we can see that these angles, they all have different starting and end points. But do you remember from theory number 2 that we said angles subtended in the semicircles are 90 degrees? They are right angles, right? From theory number 2. So this is a right angle, and a right angle is 90 degrees. Therefore, angle ABD plus angle DBC is equal to 90 degrees. And we have angle ABC, which is 53 degrees, plus angle DBC, which is K, is equal to 90 degrees. Therefore, K is equal to 90 minus 53 degrees, which is equal to 37 degrees. K is 37 degrees. We just moved 53 to this side and changed the sign. Then we are now only left with angle L. And if we look at this, we have triangle. We have this triangle, a triangle DBC like this. DBC is a triangle, and angles in a triangle add up to 180 degrees. Also looking at this is a straight line. This being a right angle, it means this is a right angle. So it means this angle plus this K and L add up to 180 degrees. Therefore, this is equal to angle DBC, which is equal to K BCD plus this angle CDB like this. This is equal to 180 degrees. So angle DBC is K plus angle BCD, which is equal to L, plus this angle CDB, which is a 90-degree angle, right angle, is equal to 180 degrees. And according to the first part, we said K is 37 degrees. So this becomes 37 degrees plus L plus 90 degrees is equal to 180 degrees. If we add 90 plus 37 degrees, what do we get? 127. So it becomes L plus 127 degrees is equal to 180 degrees. Then it becomes L is equal to 180 degrees minus 127 degrees. We have shifted this 127 to this side. Therefore, L is equal to 53 degrees. So we are done with part B. Now let us move to part C. Now we proceed to part C. First, we name the points. This is P, Q, and R. We have named the points. And the angles. Angle A is angle OPR, which is equal to A. For angle B, this is ORP. This is equal to B. For angle C, this is POR. POR is equal to angle C. And for angle D, this is PQR. PQR is equal to angle D. So we can see that from this angle, 43 degrees is equal to angle A, because the two angles are vertical. They are vertical angles. This being a straight line and this being a straight line. Opposite angles, when they are straight lines like this, are vertical. So angle A is equal to 43 degrees. Also looking at this is a triangle. These two sides are both radii. This is a radius and this is a radius. This side is equal to this side. This is an isosceles triangle. And an isosceles triangle has two equal sides and two equal angles that are opposite to the equal signs. So angle A is equal to angle B, which is equal to 43 degrees. Therefore, angle B is 43 degrees. And this being a triangle add up to 180. So these three angles should add up to 180. So we have angle A as 43 degrees plus angle B 43 degrees plus angle C, which we do not know, should add up to 180 degrees. 43 plus 43 is 86. 86 degrees plus C is equal to 180 degrees. C is equal to 180 degrees minus 86 degrees. Therefore, C is 94 degrees. Then now we are only left with D. And looking at this shape, looking at A, B, C, and D, we can see that C and D have the same starting and ending points. You see, C and D have the same starting and ending points, and they are subtended by the same arc PR. According to our theory number 2, we said angles subtended by the same arc, one on the center and one on the circumference. The one on the circumference is half of the one on the center. So angle C is equal to 2 times angle D. So we can say that angle C is 94 is equal to 2 times D. D is equal to 94 divided by 2, which is equal to 47 degrees. So we now know that D is 47 degrees. So our solution is A is equal to 43 degrees, B is equal to 43 degrees, C is equal to 94 degrees, and D is equal to 47 degrees because of our theory number 3. Now for part D, we do the first thing that we do, naming our points A, B, C, D, and we also name this point, since it is not a center, we name it E. And now we write the angles that we have. The first angle is angle BCA, which is equal to 60 degrees. Our next angle is this 40 degrees. This is angle CBD. Angle CBD is equal to 40 degrees. And the other angle that we are given is angle ACD. Angle ACD, which is equal to 10 degrees. Then the angles that we have to look for, the first angle is this angle Q, which is angle CEB. Angle CEB is equal to Q. Then the next angle T, angle ABD. Angle ABD is equal to T. Then the next angle is angle S. Angle S, which is angle CAB. Angle CAB is equal to S. Then the next angle, we look for an angle that is similar to this 40 degrees. An angle that starts with C and D. Where is it? This starts with C and D, angle V. CBD is subtended by this, and CAD is subtended by this arc. So they are similar. Therefore, we say CBD is equal to CAD, which is equal to 40 degrees. Therefore, angle V is equal to 40 degrees. Now we are left with how many angles? 1, 2, 3, 4. The next step, we look for an angle that is similar to this AD. Which one? This AD. And if we look at this ACD and ABD, they are both subtended by this angle. Therefore, this angle and this angle T are similar. Therefore, ACD is equal to ABD, which is equal to 10 degrees. Therefore, we write T is equal to 10 degrees, as it is also subtended by the same arc. Then see, angle Q is not subtended at the origin, at the center, or at the circumference. So to look for angle Q, we can see that angle Q is in a triangle, and a triangle adds up to 180 degrees. So these three angles should add up to 180 degrees. So 60 degrees plus 40 degrees plus Q is equal to 180 degrees. So it becomes 160 plus 40 is 100 plus Q is equal to 180 degrees. Then it becomes Q is equal to 180 degrees minus 100 degrees. We have moved this 100 to this side. Then Q is equal to 80 degrees. Now we are left with these two angles. Now we are left with R and S, and looking at these angles, they start and end with the same letters, so it means R is equal to S. But we do not have any other angle that is similar to that we have. We know what is it in degrees. So if we look at S here, it is in this triangle CBA, and any triangle add up to 180 degrees. And if we look at triangle CBA, we have this angle that is 60 degrees. This is angle BCA plus angle CBA plus angle CAB. CAB is equal to 180 degrees. Angle BCA is this 60 degrees plus angle CBA. Angle CBA is equal to this 40 degrees plus T. And we said T is 10 degrees. So it becomes 40 degrees plus 10 degrees plus angle CAB. CAB is angle S, which is equal to 180 degrees. So this becomes 60 plus 40 plus 10. This is 110 degrees plus S is equal to 180 degrees. We move the 110 degrees to this side. It becomes minus 110 degrees. So S is 70 degrees. And we already said that S is equal to R, which is equal to 70 degrees, because S and R are subtended by the same arc BC. So S and R are both 70 degrees. So we are done with the last question. I